Hello and welcome to a new video on the Pyoki YouTube channel. Today we're going to be talking about how I made Flappy Bird. It's took about 3 days. It was just, coding a couple hours every day. Took around 3 days to complete. And let me show you the finished product. So we have a nice little bird man here. And he just goes through the pipes. They're just basic rectangles. Oh, I accidentally fell down and died. But get the idea. You get a score of 2. Just prints in the console. And then we can run the game again. And then we can keep going. If we hit one of these pipes, the game will be over, pop, and then it'll fall down. Alright, so let's take a look at the code. So, to start off, we just have import statements, yada yada yada, JavaFX import statements, just a bunch of, single imports instead of star imports, but I think it's maybe a bit better that way when starting out. So, if you enjoyed this explanation, make sure to like, subscribe, and comment your favorite thing about the video, or how I can improve my code. I'm sure there's room for error here. So, here is all the variables. There's a lot of them. A lot of them are final variables. They're not really, I guess, organized that well. They're organized? No, they're not really organized well. There's a bunch of final variables for like the gaps in between the poles or in between the pipes, movement speed of the rectangles, right, of the arches, the gap between them. This is the gap, like, I guess, between the top and the bottom, for example. And then a random variable for determining height. And then here we just have the start for JavaFX. After calling launch in the main function all the way down here, calling launch, we come back and we call start. Or start gets overridden and called. So we're just assigning our groups to new group variables, creating an alternate pane. And we're also going to have a main pane as well. So the main pane is going to be a grid pane. So basically, the only reason I made a main pane was to get the start button in the center. So the start button is located nice and snug in the center there. So we set the horizontal alignment and vertical alignment for the start button, and then we set the background. So set the background goes to, let me search it, set background goes here. So set the background image to background.png. Can be just be found right here. So just this background image. So we're just using input stream and image view, and then setting the fit height, fit width, and then we don't care about preserving the ratio because we just want it to cover the screen. These are the dimensions that I made for the game, 1280 by 720. And then the group.getChildren.add, so we're just adding it to the main group. And then let's go back where we were. So we want to add all the objects of the group. So the group put in, I believe, just the button. Yeah, I think so. Then we make a score, start off at 0, so you can see here it's 0. Then we set the position of that. I think I wanted to put this in the group, but for some reason I wasn't able to, or I just didn't do it. And then this is a custom font. So we import a font here in the resources folder, put the path to that. And then here we see font. We could load the font as a file input stream with the new file path, set the size of the font, then score.setFont, and then add it to the score group. And then we create our scene with main pane, and then the dimensions of the screen, just set the name. We don't want the window to be resizable. I didn't decide to do that, so you can't really change the dimensions and start the game. So start game, we have a start button function, we have a new timeline, or new time cycle, which automatically starts, and then we have a function to run when the mouse gets clicked. So basically, these two things, this timeline and the mouse click, will only run if the game has been started. We can see if started in both of them. And that only gets set to true when the start button is pressed. So we only want the rectangles to start coming out when the start button is pressed. Although the timeline keeps playing. So for example, or this timeline keeps playing until the start button is actually clicked. When the start button is clicked, we should probably just set the current time equal to 0. Actually, no, we don't have to because it's actually not ever incremented. So basically once we, oh yeah, so now we want to clear these from the various games before. So we want to clear the arches, all the rectangles, we want to clear all the birds, and then we want to add the arch and initialize the bird after setting the start button to be disabled, and score.text 0 to reset the score from the previous game. So let's go to add arch. So add arch here, and we get the top arch height and the bottom arch Y, basically by random number. So we can see, for example, this top part is always going to be here, but then the height of the bar is going to change based on the random number, right? So the top is here, the height is changed, top is here, height is kind of down here. That's the general idea for that. And then so we want to draw those two rectangles, and then we want to move them, which will happen when the timeline is playing. That's the wrong timeline. When the main timeline is playing. When this timeline is playing. So for every 5 milliseconds, I believe. Yeah, for every 5 milliseconds. And then we want to say initialize the bird. So let's go to that function and cover that. So in its bird, what does it say? Idea from, oh yeah, how to build. So we need to make this Flappy Bird as the image in a label, which we do by set graphic to the image view. So we created an image view like we did in the in setting the background. Set the fit width to be the size of the bird. So this is just kind of a scaling factor. So the size of the bird is set for 60 pixels. So it's just generally a scaling factor that we can use. And then we want to set the preserve ratio to be true so that the height is properly adjusted of the bird. And then just want to, or before that, we just want to set the label to be bird X position and bird Y position. These are just initial positions of 200 and 300 respectively for X and Y. And yeah, these two variables didn't really matter, just kind of was a, you know, you can see right there, that's where the bird is initialized, right? So it doesn't really matter where it's initialized, as long as it doesn't, I guess, die instantly. That'd be pretty bad. So let's go back here. So now every 5 milliseconds, we want to change the bird's position. So we're going to say update arches and update bird position because it's only two things that are moving. So if we say update arches, you can see here for each arch in the arch group, basically all we want to do is move this rectangle and this rectangle. Or for example, if we had a bunch of rectangles, or we can just say if we had 3, and so we have 1, 2, and 3 pairs of rectangles. So we just want to move those to the left at the defined movement speed, which was negative 1.25 for every 5 milliseconds, 1.25 pixels to the left. So just say for each, what is it? Oh yeah, all we're going to do is set translate x to be the current x, which is the get translate x, and then plus movement speed, which will just move it 1.25 pixels to the left. And then here, so we want to see that if, or what does it say? Now check to see if the last added arch is a certain distance away from the right edge. If so, add a new arch. So that's where the gap variable comes in. So the gap variable, or no, the distance between arches final variable comes in. So we have this x value here. We have this x value here. And then that will be equal to this distance between these two kind of lines right here. So we want that to be constant. So there's a arch added every, I guess, what am I saying? There's an arch added every, I think it was, what is it? 500 pixels. So we're just going to say get the node of the arch group. So get the previously added node because right, so for example, this node is the most previously added node. So we want to wait until that is a certain distance away for the next two rectangles to be initialized outside the screen and then be brought in. So we want to use node and bounds, and we want to say get the min x, which will be this right here, this side, and then I think actually it'll be this line here minus this line would be some distance between the arches that we want to evaluate. And then we have update bird position. Let's take a look at that. Update bird position. So basically we're using a final velocity function, which we used for physics interface. So here I made an acceleration variable, and I kind of had to scale this in order to make it more of a human playable pace. Otherwise the bird would just insta-die. Like we could see if I even make it like 0.98, you would just lose. Like it's like impossible to keep the bird up. You have to click so fast. It's like pretty dang difficult. So 0.098 was a nice final or nice acceleration value, and then we made a final velocity in this interface. So just with a double velocity and double time, so we can find the final velocity, and then we can shift the bird, set translate y to the get translate y minus the curve velocity. And basically whenever the mouse is clicked, so we can see if I run the program, whenever the mouse is clicked, the bird gets that boost up before it falls down. So whenever the mouse is clicked, that boost up is equal to that start velocity, which is going to be equal to 1.25 upwards in the y direction. And then the current time is reset. The reason for that is to properly track acceleration. For example, if we didn't say this, then all the time would keep adding over and over and over. And then we would just die. Like it's getting harder and harder to keep it up, even though I'm spamming the thing. That's because current time is never reset. So the accelerations kind of impact just keeps adding on, keeps getting added. And we're going to say, right. So we want to set rotate when we're there before. So if object is rising up, rotate back, else rotate forward. So the basic way to show this is just by example. So for example, we can see that when the bird is traveling up, he has that upward tilt, and when he's falling down, he has a downward tilt. Near like that downward tilt like that. He's falling down, that's the main idea of set rotate. It's nice to show an example. Or nice to just show it like that. And then we want to set the translate y, get translate y minus the curve velocity. Then we want to check the lose conditions. That's right here. So basically we just want to see if the bird has either touched the sky, touched the ground, or touched any of the rectangles in the arch group. So that's what this does here. And basically, in checking the lose conditions, we also check the score. So for example, basically what this says is that the bird has traveled let's say the bird is here. If the bird has traveled here, then we want to add 1 point because it's traveled past the rectangle. So that's where we use midpoint. And we want to kind of, I guess, only update the score once. So we just see where it's equal to, where the midpoint is in between the 200 movement speed and the midpoint is less than 200. So basically what this does is it'll only check this condition one time. That's the main idea. So that for each arch passed, we'll only update the score once, which is what we want. We don't want to update the score multiple times. So we're going to find the midpoint by using a bounds variable. Then we're going to get the minimum x and add the maximum of x and divide by 2. So finding the average of the x kind of bounds. And then we want to say, or this checks for the rectangle being hit. So if it intersects the rectangular bounds, and this greater than or x position, or greater than or equal to bird x position, kind of eliminates some rectangles for not being checked. So for example, let me just run this. Wait, so we know that there was some rectangles here, right? That actually got deleted, but let's say they were still on the screen. The idea that we'd want to say is that if there are rectangles over here, there's no need to check them because the bird's x position is here and it cannot collide with the rectangles on the left of it. That's the main idea. And then we want to say if the rectangular bounds that get max 0, then we want to just remove it, right? Because that means that, so the maximum x would be this line here, and if that is 0, it means that it's off the screen, right? The rectangle is kind of here, if I were to draw it out. So we can just remove it. And then we want to use a while loop here so that we can actually remove elements mid-loop. So use while loop to delete mid-loop. That's the main idea. And then let's see, also here. So for example, if the y position is less than or equal to 0, or the y position is greater than or equal to 720 minus distance until bottom minus size of bird. So this basically just checks if the bird's, if I just kind of fall down here, it checks if the bird's kind of at minimum y, or the maximum y, because the coordinate system, the y increases as you go down, if the maximum y basically intersects this right here, which is 720. This height of the application is 720 pixels, minus the distance from the bottom, minus the size of the bird. Actually, so it's checking up here. So, because this is the size of the bird here, so it's actually checking here. Checking if that top kind of thing of the bird intersects, or if that y position is equal to, or greater than or equal to this expression here. Then we're going to say game over. So let's go to that function. Oh, yeah, that's also here, right? Because if we intersect a rectangle, then we want to move the bird to death. Actually, we can do that first. We can cover that. That's right here. Whoops. So basically what happens in this function is pretty easy to demonstrate. See, if I collide with a rectangle, then the bird comes falling down. That's basically it for the function. It just uses 10-second intervals and uses a timeline for 100 times, basically. If that makes sense. Yeah, that's it for that function. And then game over. Let's quickly go over game over. Oops. There it is. So we want to say started equals false in order to pause the timeline that is seen here. Where is it? This timeline here. So this timeline should be paused or stopped completely, if possible. So that's what we want to do. All right. Then we want to just print game over and then print the score.getText. And then we want to reactivate the start button to play again. So we saw in our start button function that all these things got cleared and disabled and reset. So all we need to do is bring back the start button and set the disable equal to false. The only thing I forgot to mention was update score. And that's a very simple function. Update score by 1 by using a substring and finding integer.value of. Actually, wait, no, I didn't do that. Forget the substring because I used to have like something like score. I used to have score written out and then colon and then would be equal to a score. But instead, I just said, let's just store a number here because that's how it's done in the original game. So just say int score equals integer.value of score.getText and score.setText equals string.format. A %d gets decimal number, and then we just want to increment score. So the only thing that's worth noting here is that this will actually not increment the score at all. We need to first, set the score equal to its incremented value, and then put it into this formatted string here. And apart from that, that's pretty much it for the game. Very quick explanation on how to make Flappy Bird. I hope you enjoyed this video. Make sure to give it a like, subscribe if you're new, and comment your favorite thing about the video once again. Appreciate all the support. Thank you very much.